Imagine an aircraft that proved more dangerous to its own crews than to the enemy. A machine so treacherous that pilots did everything in their power to stay away from it. In the hangars, it earned nicknames that never made it into the official reports. The airlighter, the flying crematorium, and the coffin with wings. We are talking about the largest and most ambitious bomber ever conceived for the Luftwaffe, the Heinkel He 177 Greif. Over the course of the war, German industry churned out roughly 1,100 of these massive planes. On paper, this was supposed to be the pinnacle of Third Reich engineering, a long-range strategic bomber. It possessed speeds that rivaled early war fighters and a payload capacity massive enough to shift the course of entire campaigns. But there's a catch. These planes barely saw combat. They rarely reached their targets, and far too often, they never made it back to base. How did an entire armada of heavy bombers, theoretically capable of flying from Berlin to New York City non-stop, fail to become a weapon of victory? Where did hundreds of bombers go? Machines that consumed thousands of tons of aluminum, millions of man-hours, and astronomical sums of money. The answer lies in one of the most tragic and absurd stories in the history of 20th century military tech. To understand how it all went wrong, we have to go back to the late 1930s. At the time, the Luftwaffe leadership held an almost religious belief in their own infallibility. Germany had just watched its air force demonstrate staggering efficiency. Blitzkrieg seemed like the universal recipe for a win. Aircraft functioned as flying artillery, clearing the path for panzer divisions. Bridges, communication hubs, and troop concentrations were neutralized with terrifying precision. Twin-engine bombers were doing the job perfectly. Poland had fallen and France had been crushed. It seemed the perfect tool for war had been found. However, some German strategists realized that sooner or later they would face targets a standard bomber simply couldn't reach. They were looking at the British Isles, the industrial heartland behind the Ural Mountains, and eventually, the United States. They needed a different kind of machine, not a tactical support plane, but a strategic powerhouse. In 1938, the German Air Ministry issued a set of requirements intended to change everything. These demands were bold, and as it would soon turn out, they were deadly. In 1938, the Technical Office of the German Air Ministry drafted the specifications for a new aircraft. It was intended to be a next-generation strategic bomber, with figures that were staggering even by late 30s standards. It required a minimum bomb load of 1,000 kilograms, a range of at least 5,000 kilometers, and a cruising speed of around 500 kilometers per hour. Its service ceiling was meant to be higher than the capabilities of most enemy interceptors. On paper, it was a general staff's dream, a plane that could strike far behind enemy lines, evade interception, and fundamentally change the geography of war. But buried within these reasonable demands was one short, inconspicuous, and fatal requirement. This future heavy bomber had to be capable of dive bombing. Effectively, a 40-ton machine was being asked to perform like a light ground attack aircraft. To the engineers, this sounded like a death sentence. Pulling out of a dive subjects an aircraft to colossal G-forces, loads that even nimble fighters couldn't always withstand. Now they were demanding it from a giant 4-engine bomber with a massive wingspan and a multi-ton bomb load. Despite the risks, the requirement was never canceled. Historians still debate its origin. Some believe the Luftwaffe command was simply obsessed with the success of the Ju-87 Stuka. Others point to the personal intervention of high-ranking leaders who trusted intuition more than engineering calculations. Whatever the reason, the clause remained in the technical brief, and it would ultimately seal the aircraft's fate. Several aviation companies submitted designs, but a favorite emerged almost immediately. Ernst Heinkel's design bureau had an impeccable reputation. This was the place that built record-breaking machines and the world's first jet aircraft. They were known for bold, unconventional solutions that delivered results. Siegfried Günther became the chief designer for the new bomber. He approached the task with immense creativity. Externally, the project looked elegant and modern. A mid-wing monoplane with clean aerodynamic lines, a single tail fin, and high aspect ratio wings designed for high-altitude flight. It seemed like everything was being done right. But the true revolution, and the true danger, wasn't in the shape of the fuselage or the wings. It was hidden under the engine cowlings. It was there that Günther proposed a solution meant to make the plane unrivaled, but which instead turned it into a deadly trap. Siegfried Günther proposed a design that, at first glance, seemed flawless. Instead of the traditional layout with 4 separate engines, he decided to pair them up. Each engine nacelle would house 2 engines coupled together, driving a single massive propeller through a shared gear shaft. Technically, the aircraft remained a 4-engine bomber. Practically, it became a twin-engine beast with monstrous power. On paper, this offered several immediate advantages. Aerodynamic drag was nearly cut in half, structural weight was saved, and that extra mass could be used for more fuel or a heavier bomb load. Those large-diameter propellers provided incredible thrust at high altitudes. The calculations looked perfect. The project promised speed, range, and payload capacity that no competitor could match. Heinkel's engineers were certain they had found a way to bypass the limitations facing British and American designers. But this layout had a dark side, and it proved to be lethal. Crammed into each tight nacelle were 2 high-performance liquid-cooled engines. Each produced nearly 1,500 horsepower. Together, they generated a combined output of about 3,000 horses. A fantastic figure for the late 1930s. To link these engines into a single unit, a complex system of gearboxes, clutches, and shafts was required. All of this operated under colossal mechanical stress and generated an immense amount of heat. On the blueprints, the cooling system looked adequate. In reality, it was balancing on the edge of the impossible. The heat generated by 2 engines simply couldn't be dissipated fast enough. Temperatures inside the nacelles skyrocketed during flight. Oil lines and fuel pipes ran dangerously close to red-hot components. It took only the slightest leak, a single drop of oil or fuel hitting the scorching metal, and it was all over in seconds. Flames, smoke, total loss of control. At a time when the project was still seen as the next big thing, no one wanted to hear the warning signs. Too much was at stake. The first prototype took to the skies on November 19, 1939. Formally, the test flight was a success, but even then, the pilots noticed troubling signals. Temperature gauges stubbornly crept toward the red zone. Wisps of smoke occasionally drifted from under the cowlings. Engineers reassured the crew, dismissing it as teething library issues typical of a new design. They promised to fix the cooling in future models. No one realized yet that these weren't minor glitches. This was a death sentence for the entire concept, and very soon, that sentence would begin to be carried out. With every new flight, the warning signs grew louder. Engine temperatures consistently hovered at critical levels. The cooling system was pinned to its absolute limit, yet it still couldn't keep up. Those 2 massive engines trapped inside a single nacelle turned the housing into a literal furnace. Any malfunction, no matter how minor, was a recipe for disaster. And disaster didn't wait long. During a test flight, the second prototype caught fire mid-air. The blaze ignited deep inside the engine nacelle and ripped through the compartments in seconds. By the time the crew noticed the flames, it was already too late. As the pilot desperately tried to bank the massive machine back toward the airfield, fire was already spewing out of the wing. The engines lost thrust, the controls went sluggish, and the plane never made the runway. It slammed into the ground miles short of the base, killing everyone on board. History repeated itself shortly after. The third prototype met the exact same fate, then the fourth. The testing program devolved into a series of funerals. Memorial services were happening faster than the engineering reports could be filed. Test pilots began openly refusing to fly the machine. Before it even reached the front lines, the He 177 had earned a reputation as a cursed aircraft. By any standard of common sense, the project should have been scrapped or the engine concept completely overhauled. No, in the Third Reich, decisions weren't just made by engineers. The Luftwaffe leadership had already publicly promised the Führer an invincible strategic air force. Admitting failure meant admitting incompetence. So instead of pulling the plug, they doubled down. They ordered the project to be fast-tracked and production to start immediately. Military brass demanded a staggering 120 aircraft per month, a figure that had no basis in reality. To meet these quotas, German aviation industry was thrown into emergency mode. It was at this moment that a step was taken that would eventually spell catastrophe, not just for one airplane, but for the entire bomber force of the Reich. The decision was made quickly and without hesitation. The troubled aircraft wasn't to be fixed. It was to be mass-produced. Military planners demanded the impossible, first dozens, then up to 120 bombers every single month. To achieve this, the entire aviation industry had to be restructured. The Nazi leadership took a step that would later be called one of the most destructive moves for the Luftwaffe. They began phasing out the production of the reliable, combat-proven Heinkel He 111. This was a plane that was already in the fight, a plane crews knew how to maintain, and a plane that was actually delivering results. Its factories were converted to churn out the new giant, the HE-177. Subcontractors providing parts for the HE-111 were either shut down or forced to pivot to the failing Greif project. The German aviation industry effectively bet the house on a plane that wasn't even flight-ready. The consequences were immediate. Old bombers were being lost in combat, their airframe hours were running out, and almost no new replacements were reaching the frontline units. By the time the scale of the He-177's problems became obvious even to the project's most stubborn supporters, restarting He-111 production meant starting from scratch. Factories had been retooled, supply chains shattered, and skilled personnel reassigned. It took months to recover, months that Germany simply didn't have. Meanwhile, serial He-177s continued to roll off the assembly lines. On paper, they were combat aircraft. In reality, they were dangerous experimental prototypes. They sat idle on airfields, were relegated to training units, or were immediately cannibalized for parts. By the fall of 1941, the situation turned critical. In-flight fires became more frequent, and the death toll rose. Even Ernst Heinkel realized things couldn't go on like this. He proposed the obvious solution: abandon the coupled engines and return to a classic four-engine layout. The wing had been designed with plenty of structural strength. Separating the engines into four individual nacelles was technically feasible. It would have solved the primary issue, the overheating and the fires. But this common-sense proposal ran into a very powerful enemy. Ernst Heinkel's proposal was logical, and from an engineering standpoint, flawless. A classic four-engine layout solved almost every problem at once. The engines would be separated, cooling would be simplified, and the risk of fire would plummet. But the decision wasn't up to an engineer. Hermann Göring categorically rejected the idea. For the Reichsmarschall, switching to a four-engine design looked like a defeat, a step backward. It was an admission that German aviation had taken a wrong turn. The British and Americans were already building heavy bombers using the traditional layout, and copying them felt humiliating. In Göring's mind, Germany had to stay ahead of the world, no matter the cost in lives. Ambition outweighed calculation. The decision was final. The project continued to stall, devouring time, resources, and men. Month by month, the Reich's position worsened. Front lines stretched thin. Allied air power ramped up the pressure. The industry was redlining. The breaking point only came when Hitler himself learned the scale of the disaster. The Führer demanded immediate action. Work on a four-engine variant, the HE-177B, finally began. In 1943, two prototypes were built, featuring four individual engines and a new twin-tail design. The result was staggering. The planes stopped catching fire. Pilots no longer had to glue their eyes to the temperature gauges every second. Flying became a job again, rather than a struggle for survival. It seemed the curse had finally been lifted. The four-engine version was exactly what the plane should have been from the start. Testing was a success, the aircraft was predictable, and the fires were a thing of the past. Even Göring was forced to admit the obvious and gave the green light for mass production of the updated version. But as before, the requirements were detached from reality. The military insisted on 200 aircraft a month at a time when the Reich's industry was suffocating. American and British bombers were methodically dismantling factories, power plants, and transport hubs. Chronic shortages of aluminum, fuel, and skilled labor became the new normal. In these conditions, mass-producing a complex four-engine bomber was a fantasy. After only 8 pre-production aircraft were built, the program was quietly scrapped. No official announcements, no admission of error. Meanwhile, engineers continued to battle the flaws of the original coupled engine version. Led by talented specialists, they achieved the impossible. Method by method, component by component, they inspected every line and connection. They identified and eliminated 56 potential fire sources. Fuel and oil lines were armored, the cooling system was redesigned, and the wiring was replaced. By early 1943, the improved A3 series began reaching frontline units. But the price of this success was devastating. Mass production had been running since 1939, with over 500 aircraft built in 4 years. Most of them never saw a day of combat. They sat idle, were used for training, or were stripped for parts. Hundreds of heavy bombers, consuming thousands of tons of aluminum and millions of man-hours, hadn't dropped a single bomb on the enemy. Their first real combat mission was supposed to change everything. It took place in the winter of 1942 to 1943, and it dealt yet another blow to the Greif's reputation. In the winter of 1942, the situation on the Eastern Front turned critical. An entire army was encircled at Stalingrad, hundreds of thousands of soldiers trapped without fuel, ammunition, or food. The German command scrambled to build an aerial bridge, pressing anything that could fly into service. This is when they remembered the He 177. On paper, it was the perfect candidate. Massive payload, long range, and the ability to deliver tons of supplies in a single sortie. The 50th Bomber Group was ordered to resupply the pocket. The Greifs were tasked with hauling ammo, fuel, and medicine. Reality was merciless. Despite the supposed fixes, the engines were still failing. In just 43 combat sorties, the group lost 7 aircraft. But here is the chilling part. Not a single one was downed by Soviet fighters. Not one fell to anti-aircraft fire. Every single loss was due to mechanical failure. Engines stalled on takeoff. They ignited mid-air. They gave out halfway to the target. These crews weren't dying in dogfights, they were dying in a losing battle against their own equipment. Stalingrad was a cold wake-up call for the Luftwaffe. Even improved, the He 177 remained a death trap. It was clear that using it as a transport or a standard bomber was suicide, but they weren't about to scrap hundreds of planes. Instead, they looked for a new mission, one that relied not on reliability, but on striking from a distance. By 1943, the Atlantic Ocean had become the war's decisive graveyard. The flow of supplies from the U.S. to Great Britain was the Allies' lifeline. Without it, the war effort would collapse. Nazi U-boats hunted the convoys while Allied escorts fought back. In this clash, the Luftwaffe played a secondary role, until a new weapon changed the stakes. German engineers had developed the HS-293, a guided glide bomb. For its time, it was a technological marvel. A winged missile with a rocket booster, steered by a radio operator aboard the mothership. Its 660-pound warhead could gut any transport ship, and its range allowed for standoff attacks outside the reach of heavy AA fire. There was only one problem. They needed a carrier. Once again, the Greif fit the bill. Its lift capacity and endurance made it the ideal platform for these early smart bombs. Hope for the project flickered back to life. On November 21, 1943, 25 heavy bombers took off, each carrying 2 guided bombs under its wings. Their target, an Allied convoy in the Atlantic. The crews expected an easy kill, but the weather had other plans. Low cloud cover made spotting targets nearly impossible, and the convoy's escort put up a wall of flak far denser than anticipated. The results were meager. Only 2 bombs found their mark, 1 transport sank, another was crippled. But the real shock came from above. A British 4-engine Liberator from Coastal Command spotted the German formation and attacked. Using its defensive guns, the Liberator damaged 2 Greifs, forcing them out of the fight. By the end of the mission, 3 German planes were lost, and 4 more were riddled with holes. Despite the setback, the command pushed forward. Just a few days later, luck finally showed its dark face. 5 days after their failed raid, fate handed the Greif crews a second chance. On November 26, 1943, they intercepted a massive troop transport crossing the Atlantic. This wasn't a warship, it was a human carrier packed with soldiers bound for the European theater. One of the HS-293 guided bombs was released with clinical precision. The operator tracked it all the way to impact. It was a direct hit. The explosion ripped the hull open and a firestorm erupted. The vessel lost all power and began to settle into the swells. There were over 1,000 soldiers on board. Night was falling. The seas were rough. Panic took hold. The rescue operation devolved into chaos as lifeboats capsized, dumping men into the freezing water. Most of those on board never made it home. This catastrophe stood as one of the single greatest losses of American life in the Atlantic throughout the entire war. For the Luftwaffe command, it was the proof of concept they desperately needed. The He 177 could still be useful. But while these maritime operations continued, a new mission was being cooked up, one that was purely political. Berlin demanded a response to the devastating Allied firebombing of German cities. The target was obvious: London. The operation was codenamed Steinbock. Operation Steinbock began in January 1944. It was designed as a revenge strike. Command knew that challenging British air defenses during the day was a suicide mission, so they bet everything on the cover of night and tactical deception. The Greifs launched from forward airfields along the Rhine after sunset. The takeoff procedure was choreographed to the second. Before the roll, a bright light was ignited on the tail of the lead plane to guide the following aircraft. As soon as the wheels left the tarmac, the pilot would flash his left navigation light, the signal for the next crew to hit the throttle. Once they hit altitude and cleared the coast, the crews began dropping window, thousands of strips of aluminum foil designed to blind British radar. They dropped the chaff in waves as they closed in on the capital. Over London, they employed a terrifyingly effective trick. The pilots would cut the throttles to idle and enter a shallow glide. This was a high-stakes gamble, but it worked. British acoustic tracking stations, which relied on engine noise, lost the scent. The bombs fell almost silently. Immediately after the release, the He 177 would nose down, accelerating in a dive to 350 miles per hour. At that speed, the heavy bomber became a nightmare for night fighters to intercept. They would cross back over the French coast at low altitude, racing through pre-designated air corridors to safety. The tactics were surprisingly effective. From late January through April 1944, German bombers hit the British capital regularly. While the physical damage was limited, the psychological impact was significant. The impregnable island was vulnerable once again. But by the summer of that year, the Greifs were ordered to a new front. This time, they were headed east. By the summer of 1944, the Greifs finally arrived in full force on the Eastern Front. A dedicated bomber wing was formed, exclusively equipped with the HE 177 and given the symbolic name Hindenburg. The conditions here were a world away from the West. There was no dense, layered air defense like over Britain. At this stage of the war, Soviet interceptors struggled to reach targets at extreme altitudes, and anti-aircraft fire lost its sting against high-flying formations. This allowed the crews to dictate their own tactics. They flew high and fast where survival was the priority over surgical precision. The Hindenburg wing struck rail hubs, supply depots, and rear area targets. Cities like Pskov, Smolensk, and Velikiye Luki felt the weight of their payloads. The goal was simple: paralyze the Red Army's logistics and sow chaos in the rear. On June 16th, one of the largest raids of the campaign took place. 87 heavy bombers took to the sky, raining hundreds of tons of explosives on Velikiye Luki. From a safety standpoint, the mission was a success. Losses were minimal, but a new problem emerged: accuracy. High-altitude bombing caused massive dispersion. Most of the sticks fell miles from their intended targets, rendering the actual military impact negligible. To the high command, these raids were becoming more of a psychological show of force than a practical weapon of war. And then, the ground began to shake. In June 1944, the Red Army launched Operation Bagration, a tidal wave that would become the greatest defeat in German military history. The Soviet offensive smashed through the Wehrmacht's lines with crushing power. Fronts collapsed, entire divisions were encircled, and Soviet tank columns began a relentless sprint to the west. In desperation, the Hindenburg wing was pivoted to a new task: stop the armor. The strategic Greifs were ordered to hunt tank columns on the move. They attacked from high altitude, carpet bombing suspected concentration areas. But a high-altitude strategic bomber is a blunt instrument, and a mobile army is a ghost. The tanks kept rolling, the columns dispersed, the bombs hit empty fields. The crews knew it was futile, and so did the commanders. By September, the situation turned hopeless. The Red Army captured the Romanian oil fields, severing the German war machine's primary jugular. Simultaneously, Allied bombers were systematically dismantling Germany's synthetic fuel plants. Fuel became a ghost. What little gas remained was diverted to the fighters defending the Reich's burning cities. There was nothing left for the heavy bombers. One by one, the Greifs went silent on their airfields. Their tanks were dry. These massive machines, once symbols of global ambition, became nothing more than hollow shells of aluminum and steel. The project that had consumed so much was flickering out without a shot being fired. But the story of the He 177 wasn't quite over yet. In the final months of the war, a desperate idea took hold in Berlin. If the He-177 couldn't turn the tide in Europe, perhaps it could serve an ally on the other side of the globe. Tokyo had shown interest in the A-7, one of the final modifications of the Greif. This version featured increased range and a heavier payload. The Japanese High Command was considering licensed production to strike American bases across the Pacific. But getting the technology to Japan was nearly impossible. The Allies controlled the seas, and every air route was under constant surveillance. German planners proposed a daring, almost suicidal plan, a non-stop flight from East Prussia to Manchuria. The route would take them directly over Soviet territory, a nation Japan was still technically at peace with. Calculations showed the Greif had the range to make the jump. From Manchuria, the plane would continue its journey to mainland Japan. On paper, it was a bold strategic move. In reality, it was a fantasy. The front was collapsing too fast. Soviet troops stormed into East Prussia, and airfields came under heavy artillery fire. The last flight-ready He-177s had neither the fuel nor the time for such a risky mission. Many were blown up by their own crews to keep them out of enemy hands. The final attempt to save the project died in the mud of Prussia. The story of the He-177 ended as quietly as it had faded away. There were no parades, no triumphs, and no official admission of failure. The aircraft, conceived as a weapon of vengeance and a tool of strategic dominance, became a symbol of something else entirely: engineering stubbornness, political ego, and a total disregard for reality. During the war, roughly 1,100 of these bombers were built, a colossal investment for a nation starved of resources. Yet most of these machines never became functional weapons. Some perished in flames during testing, others rotted on airfields. A few saw limited action with questionable results. But the ultimate tragedy lies in the body count. The He-177 claimed the lives of more of its own crewmen than it did enemy soldiers. Pilots didn't fall to enemy fire. They died from engine failures, mid-air infernos, and fundamental design flaws. The Greif never changed the course of the war. It never became a strategic game-changer. It never justified the blood, sweat, and mountain of aluminum poured into it. It remains in history as one of the most controversial aircraft of World War II, not as a breakthrough, but as a warning. It is a reminder that even the most ambitious ideas, when pushed to a fanatical extreme, can become a weapon turned against their own creators.